In the last video of signal integrity basics, we have simulated this SIG Explorer circuit with lossless ideal transmission line models. Now in this video, we'll replace these with lossy transmission lines to make it more realistic. So let's get started. In the first step, we're going to add a lossy trace here. To do that, we have to click over Add Elements, and from here click over Interconnects and select Stripline 1. Just place it anywhere you want, right click and End Add. OK. So till here we have added a lossy transmission line, which is a stripline. Now we're going to edit the property of that. To change the parameters of TLSL1, you have to just right click and click over Parameters. So to fill all the parameters from layer stackup, you have to just select the transmission line, right click, change layer, and I'm going to route this track on layer 3. So I'll just going to select it, and as you can see, if you hover here, all the information is filled from the layer stackup. For example, it's dielectric constant, loss tangent, thickness, and still we have few parameters that you can edit. So in our case, for TL2, so I'm just going to replace it with TL2, and here the length we're going to place it 3500. To add length, you have to just click here and enter 3500 space mil, and we have changed the length. Now I'm just going to replace all these transmission line or lossless transmission line with the lossy one quickly. Now let's add the properties or lengths quickly. So in TL1 we have already added the length. In case of SL2 we have to make it 350 instead of 3500. So let's select the length and make it 350. And for TL4 we have to make it 150. And this will be again 350. And this will be 750. So this is SL3, select it and make it 750. So now in the next step, we're just going to save this circuit and replace it with the existing one. Now another step is we have to change the value for R2 as well. So it will change from 50 ohm to 22 ohm. To do that, just go to R2 and change its value to 22. Now if you wanted to see the characteristic impedance of these strip lines, you have to just select those, right click, click over parameter. So as of now the parameters are already opened. You have to just right click here and go to view trace parameters. And here you can clearly see the trace impedance is 50.81, and these are all the properties of trace. So these are all the information is helpful when you are simulating to define the constraint for your layout. Now you can just close it and save it again. After replacing all the lossless ideal transmission line with lossy strip line models, we are going to set preferences. To do that, go to Analyze, left click over Preferences, and here we're going to change few properties. One is switching frequency. So in our case, switching frequency is 266 megahertz, and rest of the things will go with the default one. Now we'll move to another tab, which is simulation parameters. In the simulation parameters, we're going to add waveform resolution 10 picosecond, and rest of the things will go with the default one. Now we'll move to another tab, which is simulation mode. So inside simulation mode, make sure you have selected the typical FTS mode, and driver excitation should be active driver. After setting the simulation mode, let's move to measurement mode. And in this, make sure measurement delays at input threshold, and receiver measurement location should change to die. And click over OK. So now we are ready for simulation. To simulate it, again we'll go to Analyze and click over Simulate button. So as you can see on the screen, these are the waveform of reflection on RX and TX side with lossy transmission line on CX Explorer circuit. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.